Welcome back, everybody, to 8th grade algebra, Unit 8, Lesson 8, Part B, Completing the Square. All right, so today we're going to be able to rewrite any trinomial as x plus something squared plus something. That's going to build on what we did last time. Last time, we learned to square binomials to make trinomials, and to rewrite a trinomial as a binomial squared plus a constant. Just to show you more concretely, we took a binomial, like x plus 5, squared, and we rewrote it as a trinomial, x squared plus 10x plus 25. Trinomial because it has 3 terms. We then took something like x squared plus 10x plus 55, a different trinomial, and we rewrote it as a binomial plus a constant. That's like x plus 5 squared plus 30. Now, why might we want to do that? Well, it's useful because if we can get something into the form on the right, this one is x plus 5 squared minus 30. If we want to find the zeros, we set it equal to 0. And then we have x plus 5 squared equals 30. Well, that's useful because then we can take the square root of both sides. So then we have x plus 5 is equal to the square root of 30 or negative the square root of 30. Now we can just subtract 5 from both sides and get x equals negative 5 plus the square root of 30, or x equals negative 5 minus the square root of 30. So today, here's what we're doing. First, we're going to practice expanding binomials. We're then going to rewrite a trinomial with a positive b term, like x squared plus 10x plus something. Then we're going to do the same thing with a negative b term, x squared minus 10x plus something. We're then going to rewrite a trinomial with something that's not an even number, that's not x squared plus 10x, but more like x squared plus 7x, or x squared plus 7 halves x. We're then going to practice rewriting trinomials with any b term, and you're going to get plenty of practice. Because next time, we're going to be using this technique to solve quadratic equations, and I want to make sure that you have a lot of practice here. Okay, so we're going to start by having you try 2 things in Desmos. The first is a lot like what you did yesterday. You're just expanding this binomial squared. The second is you're also expanding a binomial squared, but this time you have x minus something squared. So I'm going to need you to draw your own diagram using the sketch tool and then enter what you get at the bottom. Go ahead and try that now. Come back when you're ready. All right, so for the first problem in Desmos, I had x plus 8 times x plus 8, and I showed that on my screen like this. And I found that the answer was x squared plus 16x plus 64. For the second problem, I actually did it on my paper, so I want to show you how I did that. Okay, so let's see how we find x minus 9 times x minus 9. X minus 9 times x minus 9. So I'm going to write x, and instead of plus 9, I'm going to write negative 9, and x and negative 9. The area of this square is x squared. The area of this rectangle is negative 9 times x, that's negative 9x. Negative 9 times x is negative 9x. Negative 9 times negative 9 is positive 81. And so my final answer is x squared minus 18x, I'm adding these two together, plus 81. Last time, we also saw that when we had x squared plus 10x plus something, and we wanted to write it as a binomial squared, we had to take half of the 10 as part of our x plus something. In this case, it was x plus 5. Now, what that means is, generally, if this is x squared plus bx plus c, we're going to take half of the b term, or b over 2, and that's what's going to go here. And then this 25 that we had to deal with, well, that was just half of that b term squared. That's the 5 squared. That's b squared over 4, or b over 2 squared. We'll get to that in a second. But that allowed us to rewrite this as x plus 5 quantity squared plus negative 30. All right, now we're going to move on to this expression that you see here. What makes this one different from the previous expressions? Well, in this case, the b term is 7, which means that when we go to take half of 7 to find x plus half of 7 squared, it's going to give us a fractional amount. That's going to present some complications, but don't worry, I'll walk you through it. In addition to that, we're going to see a trick here that mathematicians use where they add some amount and then subtract that same amount, therefore making it equal to what we started with. The reason we're going to do that is so that we can end up with the form of the expression that we want. So that we can end up with x plus 7 over 2 squared plus something. In order to do that, we've got to add an extra term and then subtract that term so we didn't change the original amount. Watch as I solve this problem, because you'll be solving one right after this. So I've already identified here our b term, which is 7. So we know we're going to end up with x plus b over 2 squared plus something. In this case, b is 7, so we know we're going to end up with x plus 7 over 2 quantity squared plus something. Okay. Well, let's just, for kicks, figure out x plus 7 over 2 squared. What would that be? Well, that would be x squared plus 7x plus that term squared, 7 over 2 squared. 7 over 2 squared is 49 over 4. 7 times 7 over 2 times 2. And then we're still going to have that plus something. Well, here's what we can do, is we can actually take this amount and we can write it over here. So we're going to write x squared plus 7x plus 49 over 4. But hold on, since we just added 49 over 4 to what was already here, now we need to subtract 49 over 4. If we add 49 over 4 and subtract 49 over 4, we're going to end up keeping this expression equivalent to what it was before. That's really important. Okay, so we added that, we subtracted that, and then, we still had this from the expression before, plus 5. So now we're going to rewrite this in the way that we knew we wanted to write it, which is x plus 7 over 2 squared. And how do we rewrite this part? Negative 49 over 4 plus 5. Pause and think about it. You're probably right, which is that you just need to add these numbers. Namely, negative 49 over 4 plus, I'm going to rewrite 5 as 20 over 4. You can see me mentally multiplying by 4 over 4, which is one whole. And so now I have x plus 7 over 2 squared minus 29 over 4. I just added these in my mind. Okay. This is the final form that we want. And so let's recap the steps that we took to get there. The first thing that we did is we identified b and knew that we were going to write x plus b over 2 squared. In this case, x plus 7 over 2 squared. We used that to find the constant that we would have had when we expanded that, and we added that constant and subtracted that constant. Then we rewrote these first three terms in the way that we knew we wanted to write it, which was x plus b over 2 squared. And then we combined the constant to figure out that extra something at the end. Now I'm going to be honest with you. This is probably the hardest concept that we've dealt with all year long. Because of that, I would strongly recommend, if you're struggling with this concept, you're going to get a little bit of practice now. But after class, you might want to check out some other videos on the internet. There are other ways of looking at completing the square. There are some formulas that you can use. I want you to find what's going to work for you, because at the end of the day, this is something that's going to be very useful for you. This is something that's going to give you admission to the colleges that you want. It's going to give you access to a lot of higher math. And if you didn't get it with my explanation, I won't be offended. I just want you to learn it in the best way that you can. With that said, the best thing we can do now is get you into practice. So I'm going to say goodbye for now. I'll see you tomorrow. And go practice and go learn how to complete the square, and I'll see you back here tomorrow. Bye-bye.